In this video, we'll discuss the most basic property of an element of electrical circuit, that is resistance. Definition of resistance: when there is a current or material, there is a motion of free electrons. You can see in this diagram, these red circles represent free electrons and these black circles represent fixed atoms in a conductor. So current is flow of electrons. So sometime occasionally when there is a flow of electron, these electrons collide with the atoms. These collision causes loss of energy in the electrons. Hence, it restricts the flow of electrons. This restriction in the flow of electrons depends on the type of material and the physical geometry or the physical size of the material. The property of material that restricts the flow of electron is called resistance, and it is designated with the symbol R. So resistance depends on the property of the material and the geometry of the conducting material. So resistivity is that intrinsic property that restricts the flow of electron. It is the measure or the ability of material to resist the electrical conduction. The units of resistivity are ohm meter. So resistance is linked to the resistivity by this equation. So R represents the resistance, which is equal to rho, which is the intrinsic property of the conducting material, into L divided by A. Rho is the resistivity of the material, L is the length of the conductor along the flow of current. This is the direction of flow of current, and this is the length of the conductor. A is the cross-sectional area of the conductor. This area is the cross-sectional area, which is height into width. Conductivity is again an intrinsic property of the material, and it is defined as the ability of the material to conduct. It is inverse of resistivity. The unit of conductivity is ohm meter inverse. Ohm meter inverse. The conductance of the material is related to the conductivity by this equation. G represents the conductance of the material, which is inverse of the resistance, and this conductance is related to conductivity by this equation. G is equal to sigma A over L, where sigma is the conductivity of the material, L is the length of the material along the flow of current, A is the cross-sectional area of the material. This table represents different resistivity and conductivity values for different materials. All these materials, they represent conductors, and these are their respective resistivity values, and these are their respective conductivity values. So now we understand what causes the resistance in the flow of electrons and create resistance in the circuit.